Hello everyone. Now we come to the most delicate part, which is choosing the right sequence to perform a multiple sequence alignment. To choose the right sequences, you have to carefully select the sequences. These sequences could be members of the same protein family or share common ancestor. So you have to know some guidelines to pick up your sequences, because it's really a bit of art to choose the right sequences. Of course, you can use any database you'd like to use, like UniProtKB or even NCBI protein database. For example, when to build a multiple sequence alignment, you have to know, do you would like to go to the protein database or DNA database? So do you would like to go for proteins or DNA? So of course, proteins whenever possible is much better, because it gives you more information, and you can turn it back after that to DNA. Don't use many sequences. Start with from 10 to 15 sequence and avoid aligning more than 50 sequences, because simply this will make a lot of problems for you. Don't use very different sequences. So sequences that has less than 30% identical to more than half of the other sequences is often cause trouble. So don't use sequences that are really very different sequences from each other. Don't use also identical sequence, because it's never help. It's also could make a lot of overlaps and problems. So try to avoid sequences that are 90% identical. But if this is necessary for your experiment, or this is necessary for your study, so it's no problem, you can use it, depending on what you are looking for. Partial sequences also make problems, so difficult comparing. Make sure with if you have short fragment or partial sequences. I myself try to avoid anything that threatens partial sequence. Try to always use the complete sequence to get the complete picture what you are looking for. Also try to avoid sequences that have repeated domain, because it could cause trouble. So especially if the number of domains are different. In this case, you can extract domains by yourself using some programs like Dotlet or Nalin. Also, if you still cannot generate proper alignment, you can of course use some local multiple alignment methods such as Gibbs sampler or Pratt. In this case, you have many steps. You can put your sequence like here, like in Pratt, for example. You can put your sequence here, this step 1, and after that try to choose the right parameters for yourself. And for carrying out phylogenetic tree analysis, you have to translate your first, of course, translate your DNA to protein as we mentioned before, and then perform a multiple alignment of your protein, and then thread back your protein back to DNA using two program, which something like Paltonal or Protogen. Protogen is a part of the TCAFE package, so you can use it also. And here you can see Protogen here turning amino acids into CDS nucleotide alignment. So you can just put your paste your sequence here, and you can submit your sequence, and that will turn the amino acids back to the DNA. So as we said, so you start with if you start with the protein, there's no problem. But if you start with the DNA, and then you can turn it to protein, and then make the alignment, and then turn it back to DNA using Protogen. Choosing the right number of sequences, as we mentioned before, should not exceed 10 to 15 sequences. This is for suitable cases, of course, but if it's more, it will make a lot of problem, including hard computing, hard building, and alignment is difficult, displaying, and of course even using the big alignment is a problem with large sets of sequences, and also the accuracy of the alignment also will have some trouble. Don't use, as we mentioned also, don't use this so similar or so different. So try to be compromised between similarity and or differences. So that's why you have to pick up the right sequence for your study. Not so different, not so similar. The general rule is that you want them to be as distantly related as possible without requiring too many gaps in order to properly align. This is a general rule that you can use. Always keep it in your mind for picking the right sequences. There's two things multiple sequence alignment program really don't like. As we mentioned, the very different sequences. So sequences that are distantly related, very distantly related, or because it will need a lot of insertion and deletion to properly align. So you will put a lot of gaps inside. Of course, how to get your sequence? Of course, you can use a lot of servers to do that, including Plus servers. So you can put your sequence, the first one you would like to search similar sequences, and Plus it, and then try to get sequences that with good annotation and experimental information. So this will bring back these sequences will bring back biological information and allow feature propagation. So that's why you have to try to find characterized sequence that is already characterized. So try to use them in your study. So that's why it will enrich your study with a lot of information. Uncharacterized sequence distinguish between conserved positions and less important columns. So you can use them only to distinguish between the conserved position and, of course, to see important places that is not mutate and other places this important that is mutate and change during the evolutionary time. Sequences that are so similar to the query are properly homologs. We commonly refer to such sequences as hits or matches. So when you do the search and you find that sequences are very, very similar, more than 90% or whatever, so this more probably is homologs. Of course, further investigation is needed, but this will give you a very good hint about what you are looking for. So we'll talk about now programs that can be used for and different programs that can be used in searching for sequences to put it in your set. So one of the program that very good to build a multiple sequence alignment is Cobalt Omega, because everybody use it. Is have a very high citation and very strong program. And it can, of course, generate a tree, and it uses hidden Markov model profile techniques to generate, of course, alignment between at least 3 or more sequences. This is how it looks like, Cobalt Omega, and mostly used. And of course, as you remember, in the last lecture, we talked that in UniProt KB they use Cobalt Omega. It's embedded in the website, in the database. The second one is TCAFE. TCAFE combine sequences, structure, and evaluate the alignment, and of course can merge several multiple alignment into one. So that's why it has many techniques and many modules inside it. So that's why it has a lot of option. So TCAFE package is very good for people who would like to have many options inside the same package. Muscle is the fastest one, and of course you can find it either in the original website, which is Drive 5, or you can find it also in API, in inbuilt websites. So and you can just paste your sequence. The good thing about Muscle is very fast and can easily deal with large number of sequences. Cobalt is a constraint-based multiple alignment tool that exists in NCBI. You can find it in the NCBI website. You can reach it easily, and it can easily you can easily use NCBI accession numbers So and it can use all the information that exists in NCBI. So that's why it's very good program for that. Also, the viewer, like MSAV viewer, multiple sequence alignment viewer, that can be automatically show a lot of good parts in your multiple sequence alignment when you use Cobalt. So how to do that? You just after gathering your sequence, you can just paste your sequence here and then align, and everything will show to you. Thank you, and let's go to the next lecture.